Okay, so I'm curious what that looks like. So we are recording. This is Kids at Science second grade training. I want to welcome everyone. Who are we? Okay, let me explain who we are. We are a nonprofit organization mainly made up of teachers, okay, who are full-time still teaching or advocates through the community supporting hands-on learning. So Liz, can you go to the second slide for me?
Of course.
Okay. So that's who we are. We formulated this group so that we can continue to get funding support so that we can keep hands-on learning. We want to make sure that kids all over Orange County particularly have an opportunity to investigate science, not just read about it. All right. So the Arno and Mabel Beckman Foundation have generously supported our trainings. The kits that you'll be getting, it's all mainly funded by the Arno and Mabel Beckman's Foundation. All right, so we want to leave you with who is Dr. Beckman and how is he able to afford something like this? All right, so we'll watch a little video so you understand the legacy of Dr. Beckman.
Born in the small farming community of Colham, Illinois, on April 10, 1900, young Arnold Beckman's interest in science was first piqued upon finding a chemistry book in the family attic. Not long after reading Steele's 14 Weeks in Science, he converted his father's tool shed into a makeshift chemistry lab. He began a more serious study of science at the University of Illinois, where he received his bachelor's degree in chemical engineering in 1922, followed by his master's degree in physical chemistry 1 year later. Throughout his school years, he also tapped into his creative talents by playing piano in silent movies to help support his family and fund his education. Beckman went on to receive his doctorate in photochemistry at the California Institute of Technology, 1928, where he also served as an assistant professor. While he was still teaching, Dr. Beckman invented the acidometer, which he first produced for a former classmate at a Southern California citrus processing plant. Designed to measure acidity levels in lemon juice, the acidometer turned out to be a forerunner of the modern pH meter. It quickly became an indispensable tool in analytic chemistry and earned him a place in the National Inventors Hall of Fame in 1987, joining other great inventors like Thomas Edison and Alexander Bell. Dr. Beckman once stated, "When you're faced with the necessity to do something, that's a stimulus to invention. If my classmate hadn't come in with his lemon juice problem, chances are I never in the world would have thought about making a pH meter." Dr. Beckman left his teaching position to found Beckman Instruments in 1935, where he continued to develop and manufacture scientific instruments, leading to the release of the Beckman DU spectrophotometer in 1941. Considered the scientific equivalent of Ford's Model T, this product not only simplified tedious laboratory procedures, it also increased analytical precision and revolutionized chemical analysis. Dr. Beckman left a powerful legacy. With his generous donations to the Beckman at Science program, which provided hands-on investigations to over 1 million students in K-6. His legacy continues with the support of Kids at Science Foundation, who will reach another 1 million students.
All right, so that is who Dr. Beckman is. Basically, a 10-year-old very curious about what science is, start tinkering around with it. And that love and that passion, that curiosity led him to become a really renowned known scientist. He is the father of the pH meter, changed his chemistry, and also ended up developing the very first DNA analysis. That was the breakthrough. All right. He's done, if you read up his history, he lived till he was 104, right? That already is a miracle. Amazing legacy he left behind. So we at Kids at Science are very fortunate to be able to get something like this. As you know, public funding doesn't continue on training teachers hands-on, provide material step by step like this. So we're very, very lucky to continue our project that way. So I'm going to introduce you to our two presenters. I have Liz Root. Can you wave to everyone, Liz? Okay. She'll introduce herself a little bit more. And then we have Diana Thompson. Okay, both of them are second grade experts, specialists, and they're going to help you delve into what is second grade Earth and space science standards for with the NGSS. All right, with that, ladies, take on over and I'll see you in a little bit.
All right, thanks, Lauren. Um, okay, well, welcome and thank you so much for waking up at 8:30. Don't hesitate if you have your jammies on or you need to get up to get a cup of coffee, or I personally have my fuzzy socks on because that's the blessing of being at home. So while it's not a dream that we all are using Zoom way too often, it's actually pretty nice moments like this where we get to be in jammies, and you guys can even multitask if you need to, but we're really super excited because it's teachers like you that take this time and wake up on a Saturday morning to learn a little bit more about science and how to support your students. And so just thank you so much for being here with us today. We are looking at the NGSS standards, so everything that we're going to show you today will align to the Earth and Space Science Unit's California standards. And on these slides, and all of these slides are shared with you, and I'll show you later how you can get them, but on these slides you can actually click onto some of these if you're just feeling like, okay, I understand NGSS, but maybe I need to see a little bit more, or I'd like to read the standards directly. I want to see how it works. I know we all have different comfort levels with NGSS as it's been pretty new the last 4 or 5 years being implemented into our classrooms. But feel free to reach out to us if you need extra levels of support or explanations on things. We're going to do a quick kind of just jumping in and showing you. Today with second grade, we're going to be hitting just the Earth and Space Science Unit. So everything we're going to show you today actually covers the frameworks and the standards that are expected to be learned in second grade. So you can see our lessons right here, and the standards are going to be everything that's starred. So if you've attended our other trainings, you've actually gotten trainings for these other units, but today we're focusing on just Earth and Space Sciences. So with that, here's our standards, and you guys can take time to read these directly. I know I read with in the chat box that most of us are all second grade teachers here. There's a couple other grade levels. This is the big unit, and I'm going to be honest with you, this is the unit I struggle with the science, because it's the landforms, and it just feels like it's not as much fun. We're not blowing things up. We're not moving around. So we did add in a bunch of good fun units that actually do become some of the best memorable, because we do blow things up in this in this unit. And kids love this one. It's rocks, which kids naturally love rocks too. So I'm not going to spend the time to go through each standard with you, because I know you guys are professionals and can do that. But if you have any questions on clarifications on what exactly each unit's addressing or each lesson is addressing, just don't feel shy, jump in. I love these moments when we're all training together, because this is when we're all professionals and so we all learn from each other. So it's so fantastic when somebody has, hey, I did this, but this worked better. Please share it, because I'll steal it. And we're all going to have, and so I love that if we can learn together and share together about what's out there. So again, more parts of the NGSS framework, what we address in the investigations. So with that, here we go. Let me introduce ourselves a little better. So Diana is an amazing person. I'm going to let her introduce herself because I wouldn't do it justice. Go ahead, Diana.
Good morning, everyone. It's so good to see you. My name is Diana Thompson. I work for Newport Mesa Unified School District and have worked for them for about 24 years now. And taught first grade, second grade, third grade, all around. And now for the last 6 or 7 years, I've been in the science specialist world. All of our schools have science labs. And so at each lab, we have a science specialist that teaches TK through 6, either an hour every other week for K3 or an hour a week for 4 to 6. So that has been what I've been doing. There's 16 of us, and so I support all of them. I do, during this year, during COVID, I am teaching online, digitally, not in person, but and then I continue to support the teachers, and not only the science specialists, but also the teachers that want to teach more science in the classroom, which I get really excited about. And I've been with kids with science. I was on the initial cohort several years ago, and then my kids were in school, so I took some time off, and now I'm back, and I'm excited because it's really great units, and I think you'll really have fun teaching them. Your kids will have fun doing them. And please, always ask if there's any questions or any way we can help you.
Awesome. Okay, and then my name's Elizabeth Root. I go by Liz, so you might see that, hear that as well. But I actually work for Tustin Unified School District. I'm a second grade teacher. I've been with the Kids at Science for I think 3 years now, since cohort 2, 3. It blends together. Time comes together. But I used to teach 5th grade, and I was involved with the 5th grade units, and I'm back in 2nd grade, which is my passion. I love this grade level. I love the little guys and all of their curiosity. So it's been pretty fantastic jumping back in and getting involved with the 2nd grade science units. I've had a lot of fun, and it's helped me become better at understanding those units or those standards, as I wasn't teaching them when I was in 5th grade. And when you come back, you're like, wait, where did the butterfly go? So I know if for some of you who might have taught for a long time, you know what I'm talking about. So I am really happy to be here with you guys today, and we can share our contact information with you guys later as well if you guys have any questions or any follow-up. But I wanted to really emphasize with you that I am a classroom teacher as well, and that I'm doing this year with you in the trenches as well. So hybrid learning is what our district has. So I'm in my classroom and I'm teaching virtually as well as in person. And so when we designed these units and we looked at how can we make this more friendly for distance learning, I really kept what I know works with 7 and 8-year-olds, with the 2nd graders, what I know that they're capable of doing, and also to kind of help support you as well as a teacher. So when we look at these units or these investigations, I want you guys to know that it's done with teaching in mind this year, as well as it's a really good way to kind of push them into that tech world where we are, so this unit that we designed, it's all going to be digital. And we chose Google Slides for you because Google Slides, I feel, are the most flexible for you to go ahead and change into what works best for you. So if it's Seesaw, it's really nice to embed them that way. Pear Deck, Google Classroom, Schoology, Google Slides seems to be the most friendly. So that's the format and the platform we chose. And you will have a copy of this so that you're able to, you won't be able to edit the investigations. Those are locked, but you'll be able to add pages in and out, delete them, and make it yours. So really want to make sure you guys know that. So jumping in, Diana and I are going to split this today, where I'm going to just kind of guide us through the slide deck and the digital notebook part. But Diana is going to be like my little Vanna White over there. She's going to be, or actually, I don't know. I don't think Vanna White's the right one. Maybe Bill Nye, the science guy. She's going to be blowing things up in her neck of the woods. And so we'll be switching back and forth that way. But the presentation, again, will be shared with you completely. So don't feel like you have to be taking a bunch of notes or writing down everything you see in these notebooks, because it all will come to you. So this, just to give you a little guideline on how this presentation is set up, you might have noticed earlier, there's these yellow slides. Every time you see a yellow slide, that's considered like a teacher slide for you. So it's something that you can use to read and understand a little background knowledge, understand what the investigation's about. It's also something that a couple of them where you can share with the students as a discussion page, as something that you can present. But every other one, the ones that are looking like our little notebook here, those are meant for your students. So this is a digital science notebook, and we've made it where it's interactive. Again, Google Slides is the platform where they can jump in and they can type in their name, they can type in their responses, they can add pictures and videos and so forth. So the notebook starts just like this. Your students would get a copy of it. You can break it apart or give it to them the whole notebook, depending on what works for you and your students. It opens up into the whole unit. So it's got a table of the contents that goes through every single investigation. And we hyperlinked the magnifying glasses too. So if you just need to get to investigation 6, you hit the magnifying glass and it'll take you down to those slides. So you're not always constantly going through slides. So we're going to give you a bunch of materials for these units, for these investigations. And that is part of your awesome gift today for being here, sponsored by the Beckman Foundation. When you leave today, we will give you a form, and when you give us your information, we'll contact you and you'll get a kit that'll be filled with all of the materials that you need to teach these lessons. And with that little note, we want to be mindful of reduce, reuse, recycle, you know, what works well. I know as teachers, we naturally hone our ways into that anyways, but I want to make a note that a lot of the materials and investigation, like 1, 2, 3, you're going to see again in 6, 7, 8. So there's notes like on what you need to hold on to, put back into your kit, and things where it's like, just toss that in the trash or do whatever you want with it. We're done. Also on that note about kits, you're going to have enough because this is that year of crazy, but there's some little bonuses to it as well. Is the Beckman Foundation has sponsored the kit so that it'll be for 30 students. So each student, whether they're in the classroom with you or they're at home, will have the materials, so that your kits are going to be a little bit heavier because it's not a group of 4 or a group of 8 even, it's one-on-one. So that's kind of cool. So again, here's your teacher slide. And so this is the one that you can use for you. So when you push this out to your kids, you understand what exactly is going to be addressed in that unit. We kept, if you've been to this training before, the Earth Science training, we used to do it in person, like we talked about. And when you do it, let that person insert. When you jump into, sorry, I kind of threw me with the doorbell. When we were together, all together persons, and we would be in that same room together, if you've attended these before, we would have you guys actually doing the activities with us. We'd be creating these activities that are obviously made for in the classroom teaching. And so we didn't want to get rid of all of that because hopefully this is going to be gone soon, this distance learning, and we are going to be back in the classroom. So you're going to see a couple things that we kept in. And the inflatable earth beach ball is one of them. Typically you would use this to throw around the classroom. We kept it in this kit so that you guys can at least use it as a model. You can show it to your kids on screen. It's like a globe. So with that, we'll just start our units. So investigation 1 is just trying to get students to understand what is the earth made of. So understanding that it's made of both land and water. And if you're familiar with the standards, we know that this is just the beginning. We're not looking at the whole composites of the earth. We're trying to introduce them. We're trying to take that curiosity, that knowledge of what they have, to start talking and sharing what they already know, and then start identifying it with the vocabulary and the way that it works together. So you're going to see things like weathering and erosion, and we are going to explain those in our units, but it's not those full units that like you see in like upper grades where it's like, how would I want to say it, Diana? Like it doesn't dive so deep that they're having to talk about nickel and cadmium and iron of the earth. It's more just these units are kind of that surface of waking up and talking about, hey, look around you. The earth is made of a lot of different things.
Yeah, introduction in the primary grades.
Perfect. Okay. So with NGSS, we start with the phenomenon. And so you just want to kind of show something to your kids to have them start asking those questions, having those I notice, I wonder moments. So we're going to start the unit with this phenomena, and I'm going to actually show it to you guys because we'll come back and we'll look at it, and it's very short. that goes on for like another minute, and you can pause as a teacher and have your students look closer. What do you notice? And this is all that drone footage where you can see that this used to be a staircase that led down to a, to a rocky ledge, or this used to be a backyard. And so what changed and why did it change? Those can be conversations that you're having. But that anchor phenomena is that piece that you kind of just keep going back to throughout your unit. Is like, remember that first video we watched on how things, didn't look the same, or what we noticed that were changed. And so it's important to kind of launch this. Diana, do you want to talk a little bit about phenomena, or do you guys need to kind of hear why that's like such a good moment? Or are you guys feeling pretty strong?
Yeah, the phenomena is very important in the biggest difference between the old standards and NGSS, because this is where we're making it real life. This is how scientists learn, and this is how they solve problems. Is there's a problem or they notice something, and how can we figure it out? So it's really, your kids will be very interested. They'll have all kinds of questions. They'll want to learn more. It will be very motivating for them. So, and then we try to go back to it. Do you remember our original? And we'll show it again. And now what do you see? And now take what you learn and let's solve it more. So it's very important.
Yeah, I love how you said it's the real life. And that's where that intimidating factor of like, oh, I can't do science. It's, chemical notations and things like that. It's what you see around you and what we learn. We're all acting like scientists all the time when we ask questions, when we make observations. And that's where I love second grade, because it's so much fun, because they do that naturally, because, we're natural learners. And they're at that fun age where they really don't, like I had to, that was a huge thing for me when I transitioned back to second grade from fifth grade, is I had to remember how many times this was the first time that these kids were hearing this. And it kind of blows your mind when you're like, oh, like this is a first for you. And I'm a part of that. Okay. So the real life connection, I think, is really huge. And second graders, they have tons of stories. Like, once my grandpa had a house and it fell off a cliff. Like, you're going to hear them, and they have that background knowledge. We just need to wake it up. And so that's how we're going to start the unit. And just to show you a little bit more about the notebook, if you see up in the corner, there's these little yellow boxes, and it goes with the 5 E's that are part of the NGSS. And so the first part is engage, where you want to engage your students. You want to get them involved. You want them to care about what they're learning so that they're ready to dive in and ask more questions. So, let's see. Okay. So here again is a teacher page. So you can choose to do this if you want. And here's another piece, like, as somebody, again, who's every week, exhausted. I'm sure you guys are feeling it, because we're working more hours than we ever have. And we're trying to make this work for our munchkins. And I know that science right now is difficult to kind of implement in there, because you're so worried about reading standards and math standards. What's awesome is that we integrate so much of what we're doing with those reading and math in science. So it is kind of one of those nice topics that we can do that integration with the reading and as much. But also, I know that sometimes you're like, I just need to share it with them. And so all of these yellow slides are ones where you can be working and talking with them, but also know, like, you can push out some of the notebook on their own, and it really does walk them through it. So if it has to be asynchronous work and you just want to make sure they're getting some science this year, it's a really nice option for you to do as a teacher as well. So we appreciate all of your hard work and loving keeping that science alive for them, because I know it can be really difficult to try and get all the subjects in. So with this, it's just a know and wonder chart. You can do this with them old school with pen and markers. You can do it with a digital whiteboard on Zoom. You could do it with Jamboard, Google Slides, Padlets. There's tons of different ways that you can integrate this. Does anyone else have any suggestions or ideas? Are you feeling like it's just that discussion board that you guys have probably been doing with your kids? Do you have you guys been using Jamboard? The kids love it. Jamboard's really easy. If you use Meet, there's a link right in the bottom where you just open it up, just like how in Zoom, there's the whiteboard. Okay. All right, I know I feel like it's so weird being quiet because I'm usually like, the meets are so loud. And so I'm like, okay, you guys are there, but I'm totally good with it. Okay, so investigation 1. You're going to do a lot of describing. This is a lot of observations, and you want to record what you see in the images, and you think about what you know about the planet Earth and help you to decide. So there's even in the notebook, we put little tech tips on how to navigate through editing the slides, on how you can type into the boxes. So we put those in there to kind of help for some of the students that might not be as familiar with using Google Slides. And again, you can also import these into something like Seesaw or Pear Deck if that works for you. Okay, Diana, do you want to talk about this, or do you want to wait for the hands-on?
Yeah, I can do the hands-on.
Okay, so first one's just, hey, what do you notice about the Earth? And so again, with that beach ball activity, we'd be tossing it around the room. They would be looking at it and noticing that every time, like you could ask them, like when it lands on it, like what is your finger touching? And most of the time it's going to be touching blue and not the greens or the browns that are also on that beach ball. Or we can look at this digital image of the real Earth, and you can see, like, what do you see and what do you wonder? And for a lot of kids in second grade, they're going to know, like, that these are the oceans and this is the land. They might even know what continents they're seeing here. They might recognize the moon or even the clouds. This is that intro, again, engaged, to get them to start waking up and noticing, like, this is what we're going to talk about. So continue the investigation for a few slides. And then the question is, what do you see most? What color do you see most? And that's that blue. And that comes to the science that we're trying to acknowledge and wake up with them, is that the Earth is covered by a majority of water. This is the breakup for you. Again, it's a yellow teacher slide. You do not have to have your students memorize this. They do not have to know 97% of salt is, they don't need to know this. That's all in, that's all really just background knowledge to help you. Okay. So I'm going to skip the videos. You guys don't need to see those, but this again is where your students can walk through it, and you can look and you can say, yep, that's right. You guys were absolutely right. The Earth is mostly made up of water. And this is a quick little video that shows and explains how the water is distributed on Earth and how we can find it in oceans, rivers, lakes, glaciers, and even in underground aquifers. And then it has just a little check there. And so again, talking about the notebook, this becomes an explain page.
Space Place.
Oh, I'm going to skip you. Okay. So continuing with that, we're going to be now saying, okay, we've talked about the water. We know all those different waters there. What's the other big thing that covers Earth? And that's the land. And so we're going to start looking a little bit more at the landforms. And so we'll start this. And I don't know, I haven't been to Disneyland in a really long time. I guess nobody has at this point, but that Soaring Over California ride was one of my favorite rides there. It was just, I don't know, it blew me away every time. We'd wait the hour to do it. It was a family favorite. And so we'll start that by kind of, that's in here where they're going to look at that to kind of make identifications of, look at how just California is different. There's going to be some thinking maps activities in here where you create a tree map and organize your thinking of what type of landforms. And then there's the hands-on activity, which they love the most. And so right here, you'll see these are the materials that are provided for this. And these are some of the vocabulary words that your kids will be coming up with. And so it says play clay. It's just the non-commercial use for it's Play-Doh. So we just had to call it play clay because it can be anything that you can form. So I'll jump into those lessons. So the science is, let me get out of that. The science is discussing how the Earth has many types of land masses. What kind of landforms do they see? What kind of landforms do you already know about? And just understanding that real key vocabulary word, what is a landform? So I keep hitting the other page. I just want to turn the slides. Okay. So recognizing that the Earth is made up of many different shapes and forces. And so we'll think about that and do that engagement. This is a video of soaring over California. And I'm not going to play it for you guys, even though I know some of you are like, please, please, I want to. You can play it yourself, but it's so much fun. And it really does show like the rivers, the lakes, you know, from San Francisco, California. I mean, I've always said we could be a small country with everything we have. We go from the snow to the deserts to the oceans. And so it's fantastic. Plus, especially here in Orange County, where I know most of us are all from, they relate with Disneyland. And again, I know it's not soaring over California anymore in that ride, but some of them might remember it or they'll make the connection. And having that engage of, hey, I've been there is even better for your learners. So it starts out with looking at pictures and just seeing like, what do you see and what is it made of? Is it land or water? At this point, we're still in the engagement. So they do not have to have the actual vocabulary. So we're not looking for them when they look at these pictures to say, oh, I know for sure this is a mountain range. If they call it something else, that's okay. We're just trying to ask them, what do you see? So like on this picture of a valley, they might not know that it's called a valley, but they might say like, I see steep sides, I see, you know, flat land, I see something going through it. And that's absolutely okay. The two main things we want to see in this part of the investigation is just, what do you see? Be an observer, talk about what you see. And then, hey, do you think it's land or do you think it's water? And so that goes for a few. And then so some of them will have the answer of it's both land and water. Okay, and so at the end, they're going to reflect and they're going to say what, there's always a reflection because we know as learners, it's really important to reflect on what you just learned. And do you have any unanswered questions to keep that alive? Since this is a notebook, it's a digital notebook, clearly they can go back to these pages and that's what we're going to want them to do as well. So moving into the explain part, we're now ready to tell them, hey, you just looked at landforms. Let's give those landforms names. And this is a very popular activity because it's all done with Play-Doh or play clay. And what they're going to do is they're going to take that Play-Doh and they're going to have it shape it into the different landforms. So you can also, talking about how that engagement of making connections with what you know and where you're at, you can talk about peninsulas because we know about the Balboa Peninsula. You can talk about the hills in San Joaquin. You can talk about the coastline pretty much everywhere here and the mountains that we can see as well. So talking about everything that we see around us, going to Catalina Island, the Channel Islands, it's pretty phenomenal that they'll start making those real life connections. There's a landform video in here where they'll watch it and see that definition, hearing exactly like, okay, that is a mountain, that is a valley, that is called an estuary. They'll start learning those names. And then we have a little check for understanding with the box here, where it's just write 3 facts of things you learned. Take a moment. So that goes to the hands-on part where it's building a landform using play clay. Were you going to do this one, Diana, or like
No,
skipped it? You guys probably don't need to see this.
Kids can do this one forever, you know. And so if you're even doing distance learning, the kits will come with play clay that the kids can do at home and build different features so they can practice, you know, building a mountain or a valley or whatever they like to.
Yeah. So the activity here is just using play clay, making different shapes, making different landforms, using that so that, because the key idea is for them to start recognizing the features of what makes a mountain a mountain. And it's like, oh, I have to create really steep sides. Well, when I make my hill, it can be shorter and more rounded on the top. And so it's a really fun, really, the kids love this one. And you can use tech by inserting the images into here. So like, I know a lot of schools have iPads and Chromebooks. So just snapping a quick photo. If that's like too much for your kids, you're like, we can't, you know, it's just, I'm not there with it tech, you know, you can always modify any of these lessons to what you know your students can do. So don't be afraid to like say, that's okay, draw a picture of it on another piece of paper and submit it to me. What works best for you? It can be a drawing, an illustration, a photograph. Of course, you guys know to modify this any way that feels good. Okay, so.
Yeah, I know when I'm teaching my hybrid, I'll have some of my students will be able to do that. They'll put it in their notebook, but then whenever we get back together, I say, oh, does anyone have their pictures that you want to share? And then we'll all share as a whole group and we'll talk about the pictures. So it's kind of nice to offer both, but you can see how that lesson is really easy to do with distance learning. You can just send a couple of those or assign them for asynchronous. The children will have some time to think about it, write their responses, and then you can all discuss it when you're all together.
Yeah, perfect. And then at the end, don't, it's not take every landform we just learned about, it's choose two. And there we incorporate the choice where they can say, I want to talk about mountains and I want to talk about hills, or I want to talk about valleys and islands. So they're being able to be the expert and have the choice on what they want to form a tree map with. The tree map might be new for your students, depending on if they've learned it before, but we included a model in here where I put mountains there. And so they'll see this. This is their notebook. So they'll have a sample of how to do this work in the start. And then they have their own tree map on here where they would be typing in here and they can name it and fill it in. So good little check for understanding. Okay, so we've talked about landforms. Now we're jumping into the other part of Earth, which is the bodies of water. And so it's another video that talks about the different ways that water exists on Earth. They watch this video. Again, I'm going to skip it. You guys don't need to see it. But it's about 3 minutes long, and it just has that check to make sure that they did watch it, as well as a moment of reflection where they can add 3 facts. And then it goes through the same type of lesson we just did with the landforms, but now we're doing it with water. And so they're looking at this and they might be like, hey, I know that's a river, and they're going to type it there. Or they might just be able to say, I think that's water. I can see it's moving. It's not very big. It has land on both sides. There's really no wrong answers because this is that engage portion again, where we're asking them to notice and get involved into what they're learning. So there's no moment where they have to feel like they're wrong. There's no wrong answers on this part. It's what do you see? What do you notice? So in here, and some kids are going to know right away what these are. Some are going to say, I've never heard it. There's a video that actually explains what they are. So like this one is an estuary. So this is a video all about like, what is an estuary? What counts? Actually, I think this one's a lake. I take it back. Okay. There's the estuary and the ocean. Whoops. Okay. And then at the end, we have that moment where your students have been exploring, but now we're ready to explain. Like, you're right. The Earth has many different types of land masses. Here's a list of them. The Earth has many types of water. They come in solid and liquid, and it can be found on Earth in these types of bodies of water. Okay, that jumps us into number 2. Okay, finally, Diana, I feel like I'm dominating the conversation here, but here we're gonna have some activities. So again, it goes to the yellow teacher slide, and then the white, the notebook pages are the students. So do you want to talk about this one, Diane?
Yeah, this one is just the shake test, basically activity. And so you'll have 3 little cups, and we're going to use chalk as our metamorphic rock, and which technically it is, but chalk is one of the softer rocks that will break down quicker than a regular rock. And I've done this all the time, many years, using glass jars, or you can use plastic containers. You can almost use anything. So this one, okay, can you go ahead and change or go to the next page here? So how can we describe rocks? We're looking at rocks, and many times when I'm teaching this unit, students will bring rocks in to me. Look, Mrs. Thompson, look at this rock I found. And they're all excited. Do you know what kind of rock this is? And I say, well, I'm not sure, but we can look at a ID book, or we can just look at the different properties of it, and if it's shiny or whatever. So, but it's neat to get their interest. And I've even had some students start little rock collections at home. And then go ahead and switch. And so then we talk about what happens when rocks smash each other, what might cause rocks to smash our grinding against. They talk about, when I pick it up and throw it, and I say, well, what in nature would happen, and we talk about water and wind and all of those things. So these are some questions you can ask for speaking and listening. So number 2, scientists learn more by doing experiments to prove their ideas. So you put 3 metamorphic rocks or chalk in a container with 2/3 cup of water, put 3 rocks in a container without water, and then draw pictures in the containers. And you just shake the containers for 10 minutes a day for 5 days. And after the first day, you observe and you draw a picture of it. And then before you start, you make a prediction. What do you think is going to happen to the rocks after shaking them? And then here again, they can either draw or insert a picture, or at least draw a picture and share the next time you meet. So of course, the first thing, where there's no water, the rock will hardly change. That's the idea of it. And then when the second row draw after with no water, shaking the first day. Okay, yeah, this is all the no water. So pretty much they're going to notice over time there's no change. And then if you want to go the next here with the water, they will notice the change. So let me change my video here. So to my dock camera, I just have these little cups here. Hopefully you can see it. This is like one with no water, and they'll shake it and nothing will happen to it. Hopefully you can see this. And then this one is one, and I'm going to try to turn my camera here so that you can see the layer. Can you see the layer there of how after 10 days the rock will make a layer with the water? Do you see that? As it breaks down, and as they're shaking it, they won't notice the layering, but you'll just tell them, okay, let it sit and watch what happens, and they'll see how it will settle, and then they'll have a rock layer. And this is the basics of how sedimentary rock starts forming. So it's nice for them to see how, oh yeah, it does separate, and the rock does layer. So that's a pretty simple one. Simple activity, but the kids love shaking the rocks and the chalk and seeing it erode. And so then what did you learn from this? In conclusions, what may cause rocks to grind and smash against each other? Hopefully they'll, say the water. You can talk about how glaciers break down and they get into the rivers, and then the rocks go down the streams, and then they go out to the ocean, and then on the waves. A lot of our students have gone to the beach, and you can just say, just imagine 24 hours a day, all the time, just wearing down into pieces of sand. And that's how it gets so little. And then what did you learn from exploring the rocks from being shaken in the container? Again, just that, rocks do break down and weathering. And what do you still wonder? They might say, some rocks are faster than other rocks to wear away. And then this is the weathering part. And again, we have a video, and tell us in your own words, what is weathering?
So there's the kids, they did the experiment. They were actually recreating weathering, but we didn't use that word yet. It's like, now you're helping with that explain. You're like, okay, this is weathering. So it's a little different than probably how we've taught in the past, where you're like, this is all the vocabulary you're gonna, need, and let's talk about what this means, and now let's do the experiment. NGSS kind of flips that. It's more investigating, and then understanding, and then the explain. So now they really own weathering because they just did it. They understand it a little bit more.
Right. We rather that the vocabulary is taught after they do the hands-on experiment, and then you attach the academic vocabulary to it.
Yeah. So a quick video on weathering. We don't need to watch it.
Yeah.
And then that moves us into the next two investigations. Again, you have teacher pages here. So this is investigation 3 and 4, and it's talking about the standard, how things on Earth change fast and things on Earth change slow. So we just had that activity where they're shaking the rocks, and they had to do it for 5 days, 10 minutes a day. So you're gonna ask, like, did that take a long time? And hopefully we're making that connection that weathering is something that takes quite some time. But we have the opposite world. And so again, if we're integrating our curriculum, you could be talking about antonyms here. You can say what's the difference, opposite of fast and slow. So we're looking for what kind of fast changes. So here's the fun, like this is where we're gonna blow stuff up. This is the one that the kids talk about all year round. And I'm sure you guys are probably done it or something like it. It's the whole volcano in your classroom. It's the classic science experiment. And then we also have another piece with the earthquake kit. Now in, I don't know, I always want to say normal world, but I don't know, pre-COVID world. This earthquake lesson is actually a STEM lesson that they create on their own, and they test on the simulator. We didn't want to take away the simulator from your kit. So it's going to be a teacher only demonstration, which Diana has too, and she'll show you a little bit more. But just know that there's a little bit of, there's some stuff in there that we have visions that you'll want and have in the future when we're all back in the room together. But in the meantime, here is Diana's volcano. Can you guys see it big in there, or does she look small like a, are you guys seeing her screen nice? Like you can see her experiments. Are we feeling good? Thank you so much for the thumbs up. All right. Okay, Diana.
Okay. So here's our volcano, and I wish we were all in person to do this, but volcanoes are really fun. You can really, the kids, there's so many different ways that the children can make volcanoes. I've seen paper mache, I've seen, you know, out of paper even. And this lesson we use Play-Doh. So again, going back to the lesson, we look at volcanoes, and do you think volcanoes causes changes to the earth quickly or slowly? And look at the two pictures. And again, when they're older, they're going to learn the different types of volcanoes. But right now, we're just introducing them to them. So we have a volcano eruption here, which is so exciting. The kids really love it. And I let them know that here in California, we don't, in Costa Mesa or Orange County, we don't really live near a volcano. But if you drive up 395, you'll notice on the way to Mammoth, you'll notice big lava rocks to the right, because at one time, Mammoth area was a volcano. And that's probably the closest one to us. There's more up in Northern California, but I always tell them, you know, we don't have, right now it's not active. It's, you know, but Mammoth actually does have quite a few earthquakes and stuff. So, but so that's probably the closest place, but they may, some of them may have gone to Hawaii, and they may want to talk about those volcanoes and things like that. So this one, we just use Play-Doh. You'll have a small bottle, and I kind of pre-did this to save time, but you just put the bottle in a foil pan, plastic bottle. And again, you can pretty much use anything. And then I just use the Play-Doh around it. And then I don't know if you can see, but I put these little Lego buildings to pretend like they're houses, and some rocks and gravel around it. And so so hopefully your students with parent help will be able to do this at home if they're at home. If we were at school, I would do it outside for sure, even out on the grass, you could do it. This is kitchen science. So you're just using baking soda and vinegar. It's nothing really dangerous or anything, but again, you know, let them know that don't taste it, don't, you know, get it on your hands and then rub your eyes or anything like that. But it's pretty safe stuff.
Just to interrupt you real quick, Diana, there is the option to put food coloring in. Like some people want to do that. I stay away from it. There's no reason to have red food coloring all over, like, but right. You don't need it. It's just as exciting. And then there's the option of doing like a couple drops of dish soap which just
Mhm.
makes the texture change a little bit. It's more oozy.
Yeah, more bubbles.
Yeah. And so you can do that as well, but we didn't include the dish soap in your kit, but it is something that if you're like, oh, now try it with this, did it do it different? You can always do that as well.
Yeah. Yeah, definitely. And I actually, in this bottle, I already put the vinegar, and I have a funnel, and I put a couple drops of red vinegar or red food coloring in there. But again, if I was at school, I probably wouldn't use the red food coloring. So it's basically vinegar and baking soda. Now, some people put the baking soda in first and then add the vinegar, or you can put the vinegar in and then add the baking soda. I usually have more luck when I have the vinegar already in and then add the baking soda, because sometimes the vinegar will stay on top of the baking soda and then it won't go through all the baking sodas. So here they're gonna make their model. If they have little plastic plant pieces, or even if they go outside and get a couple leaves or branches, they could stick that in their model. They can really do a lot when they're at home or at school. Okay, so now I'm going to, the vinegar's already in there. And now I'm going to add the baking soda. I'm just going to use a funnel to have it go. So it's going to happen quickly. So just, you see it?
Like, ah.
That's it. So it happens really quick. The kids, and you can even hear it. I don't know if you heard it, but you can hear the fizzing. You can see the bubbles. You can see how it looks like one of the houses actually did move off the volcano. So that's kind of like what we wanted them to see, is how volcanoes changes the land. And yes, they will love this at home. So, and it's pretty easy to do. And I think parents will like to do it with their kids too. So that's the volcano one. If you want to flip the page.
Yeah, Diana, you are small, so I do want to see if I can make you bigger.
Oh, okay.
I'm trying.
Liz, if you stop sharing,
do I have to stop sharing to make her
you do
big?
need to stop sharing, and then let me remove your spotlight.
Now you guys can see it better now, right? Yes. Yeah. Okay.
Yeah.
So
So part of Zoom is that when you're sharing, you're splitting the screen. So just stop sharing and then focus on the document camera. And then I spotlighted only on Diane's,
do you have more baking soda, Diane? Do you want to do it again?
Oh, sure.
That's it. The kids love repeating this over and over. When I've done it in groups, like they fight over who gets to add what. An alternative, because like funnels, you might not have it. You can just take a piece of paper and show the kids how they can roll it into a cone. That's a good option too. But let's watch it explode one more time. Do you have it, Diana, or is it a problem?
Okay, and again, it doesn't have to be the exact recipe. That's what's nice about this whole thing. You don't have to be like perfect. Okay, bear with me. I'm going to get some vinegar here. So I'm just measuring 3 tablespoons, but really it can be anything. It doesn't have to be perfect. And vinegar and baking soda actually cleans a lot of different things in your house. I don't know if you've read, but my husband was like, oh, I clean the drains with that. I'm like, yeah, we do volcanoes too. So, okay, I'm going to pour the vinegar and red food coloring in first. Oh, shoot, there's still a little bit of baking soda in there. Oh. So.
Perfect.
Okay, let me put some more baking soda in there.
And we added, so in the kits, we added some little plastic plants, and the gravel is part of the kits too. There's little Lego houses, or they're actually Monopoly houses. And go ahead and let them add that to their models. because it sounds, I don't know, I guess
Oh.
that does sound kind of dark, but we want to show them that, like, when that lava explodes, like, look at what it's covering. It's covering up, things that used to live there, like the plants or possibly homes or rocks, and it's going to change it. So it leads to a really good discussion, like looking at all that lava, it hardens. I always tell the kids, because Hawaii is one of my favorite places, I'm always like, oh, you gotta love the volcanoes because they're creating more beachfront property. So it's really good to have all of those discussions, and they can see it and make those connections with their models.
And I don't know if you can tell, but you can hear it popping, and you can see the bubbles, and even in the pan, and they can see if you do add a little bit of soap, I mean, just like a drop of like Dawn or dishwashing soap, it will make a lot more bubbles too. That will move slower. That usually slows it down. So did that
was
go
awesome.
okay?
Yeah,
okay.
Awesome. Let me get to, I'll share a screen again.
Okay. I'm going to move this to the bathroom.
So just like any good science experiment investigation that we have, you're going to have those recording into your notebook. Like, what did you see? What were the changes? What, and so again, they can type it right in if you're not feeling as tech savvy, or you want them to have that traditional science notebook where they're drawing it and writing it. You can totally change this to insert the photo of your notes right here. Or so you can make this all work best for you. I love, like, I know for me and my team, we're constantly sending home learning kits this year because you can't give them all tech. They're 7 and 8. We need them to be writing and cutting and working on those fine motor skills. So again, you always want to make sure that it's working best for you. This is a tech challenge if the kids wanted to turn their volcanic eruptions into a movie. And you could literally just put it up with what, like Diana just did, where it's a really quick, simple, this is what just happened. For your kids who are very excited and want to get into that movie version, they could create a iMovie intro with the trailer features. They could incorporate real pictures. They could have sound effects like, whatever works for them. This is more like a tech challenge. It's not a, you don't have to, but that video posting, and we know kids nowadays are pretty good at posting videos. TikTok taking over the world. Okay, so reflecting on what changed and looking at that big key part of our standard. Did what happen very fast, or did it happen very slow? And then forming that conclusion, forming a conclusion at the end of your experiment, and understanding that how it can cause changes to the Earth's landform. So again, that's where that model, where how like Diana had the rocks and the plants and the houses there, that's going to be a definite change. And with a video that we showed earlier of an actual volcanic eruption, they're aware that it's actually lava and molten rock. So you can say, like, let's imagine, is that tree going to be okay? Or those houses going to be okay? And they're probably going to be able to form those conclusions. So this would be your evaluating page, that E, where you're checking to see, like, okay, are we understanding what we're learning? Now, while we've told you throughout a lot of the lessons, don't tell them the answers, this would be the time to tell the answers, to clear up any misconceptions. So if they're like, the volcano's fun, I'll go swimming. Nope, or it's really, really slow. It took me forever to put the baking soda in. It's like, okay, now I'm allowed to talk and explain it to it. So when you get to that evaluate part in any of the NGSS lessons, if there's those misconceptions, feel free, this is the time to make sure you're explaining it and making sure that they're understanding the science. And if that means going back and revisiting parts of the lessons, reteaching, that's your professional prerogative. And I know you guys are experts in that. This is a reading connection, and it's a story by Thomas P. Lewis. It's called The Hill of Fire. And it's an older book where it talks about the volcano. And so it's not a folk story, but it talks about a volcanic eruption in a small rural town and how the people had to leave. So it brings that human connection into it, as well as you're reading a story and integrating that language arts. So that's actually a video of the story. I will let you guys watch that on your own. Just in being mindful of your time. I know you guys don't need to sit and watch the videos, but that one is actually a really cool story for you to, if you want to look at it. And it's also, as Diana was saying before, we don't have volcanoes here. So it's kind of nice to see like where people, the native cultures, how they explain it. Okay, so working into investigation 4. So we're still talking about those fast and slow changes. So we're going back to not only volcanoes are a fast change, we want to understand that earthquakes can change the world really quickly. And that is one that we can make a very strong connection here in California. I haven't had, let's knock on wood, I don't even want to say too much, but we haven't had one that's noticeable recently, but 7-8-year-olds, they usually have 1 or 2 in their background knowledge that you can talk about. If we haven't had one that they remember, they are at least probably aware of like earthquake drills and why we have them. So that connection, that prior knowledge of how an earthquake can quickly change is something. This is one where you're going to get a lot of stories like, and then my TV fell off the shelf or whatever it is. They usually definitely have some prior knowledge here. So this is the same idea. It's going through the same questions again. Like, so what do you think after watching this video about earthquakes, and it shows a lot of damage and destruction? Was it a slow change or a fast change? And I'll say, I know it was because. I teach my kids my favorite word is because you have to back up your thinking. Not my favorite color is blue. My favorite color is blue because. So in any answer, language arts or science or social studies or math, that because word will push that answer to be even stronger. So that you'll see in a lot of these answers are that I know this because, like, give me evidence how you know it's a fast change. So that takes us to our earthquake simulator. And again, this used to be a STEM challenge, or it is a STEM challenge in the unit that was created for this, the investigation that was created for this unit. But because we're at home and this is actually kind of an expensive item, we couldn't provide 30 of them for everybody, or for each of your students to try it, but we did provide one for the teacher. And so it is basically building a structure that can withstand an earthquake of a certain magnitude for at least 10 seconds. And so this is a survive the quake demonstrator. I think it's from Lakeshore. It's really cool. But Diana and I were both like, that has to stay in the kit. So you're each getting one of these, which it's one of my favorite pieces because I don't know, it's also kind of like a toy. Like if you read the reviews on it, most kids got it for Christmas and they spend time making buildings and knocking them down. And that's just classic fun. So yeah. I'm going to stop sharing so that you can see Diana big again.
Yeah, I wanted to show you it because this is like $50 right here. So it's expensive, but it's nice that it's in your kit and that you have one. So when you're back in person, they give you blocks where the kids can build, but what's even better is let the kids come up and decide what they want to build their homes with. They could use popsicle sticks, pipe cleaners, straws, paper, whatever, and you can have constraints too. You can say, okay, you have 2 pieces of paper, that's it. Build the house, you get 1 little piece of tape, that's it. You know, if you're low on supplies, and then say, now we're going to test it. So this is a really easy shake table. The ones we use in the lab, we actually made, and they're not as nice at all. So I'm so excited you get these. And I just wanted to show it to you real quickly. Here are the little blocks. And then here is the simulator. And you just put in some batteries and then you turn this knob. And what's nice, let me make sure you can see the knob, is it has 1 through 5. So the nice thing about engineering is that you can change the constraints and criteria. So you can say, okay, which houses survived level 1? Okay, and then you could say, okay, now let's see which houses can survive level 2, level 3, level 4, level 5. So it just allows you to do a lot of different things with this. Or you could just have each, usually I have a team of students build a house instead of each student. And we'll say, okay, let's put it on there, and you have 3 minutes at level 5, and let's see which one is the strongest. So there's all different ways you can use this. But the table shakes, very easy to use, and the kids do love it. So if you're in a hybrid, maybe you could have the kids build a house at home. You know, let them send some popsicle sticks or something, and then they could bring it in and you could test it one at a time, 6 feet apart or something like that. But it's definitely take advantage of that, because that's a nice tool for teachers to have in their classroom.
Definitely. Okay. Yeah, so you guys are all getting one of those, which is like, I don't know, I always feel like it's not Oprah, like you get one and you get one. But like these kids just come and you're like, because I get one too, and I love that. But when they come, it's just amazing to see like everything in there, and it's just such a generous kit. There's always, and making it for 30 right now with the kids is just phenomenal, because it's a lot right now, and you want to get these kids engaged, and when they're sitting behind that computer, if they have that hands-on material that you can send home, it's really does make it a game changer. So again, you don't get kits or the earthquake simulator for everybody, but you do get one for yourself, and hopefully that'll be a little treasure that you can use as you continue. And as we know, the earthquakes concept, it comes in different grade levels too. So you probably will be able to, if you ever have to move, use it in the other grades as well, or even in a fun STEM challenge.
Yeah, earthquakes is taught in 4th grade again. In fact, there's a whole unit on earthquakes alone in 4th grade. So they definitely will. So just remember, this is an introduction. In 2nd grade, you're just introducing all these concepts. They don't have to have mastery. They don't need to know the nitty-gritty details, because they will get it again in 3rd, 4th, and 5th. The nice thing about NGSS is it spirals, and a lot of these concepts are built onto each other. And also sometimes my students do get scared about talking about earthquakes. So I let them know that they're safe at school, they're safe at home. We practice every month at school, earthquake drills, and you should know where your flashlight is at home and all of that. So sometimes they do get a little scared or nervous, but I try to let them know that, we're safe, and our buildings are built in America, very, very safe, where in other countries, they may not be as built as well. So just be mindful of that too, that you may have some children that get nervous about it.
Yeah, and it leads to great conversations. Again, these are ones that we can make some definite connections to, especially in 2020. We had some great wildfires. I know personally, our school evacuated, and we're walking down the hill to escape the last canyon fire. So wildfires, is that something that happened quick? Is that something that happens slow? Are there natural disasters, mudslides, things like that? I don't know. I hope you guys all did really well with the wildfires. I know we're all Orange County friends here, and so hopefully not too many of you guys had to evacuate. But if you did, I'm glad to see you safe now. Some other ones that might be a conversation, there are definite conversation of the natural disaster with if it's fast or slow, but ones where they can make personal connections, or things like the tsunami. I live down on the beach, and we have tsunami signs, and we have first Friday of every month, you hear a big horn, and that's the tsunami test. So those are conversations that kids might be aware of, and you're going to ask, is that something that would be fast or slow? Tornado. I always go Wizard of Oz with that one, because we don't see them as much here in California. But talk about other natural disasters. And I know there's some really good reading connections you can make with these, like small group reading, that with different books and different nonfiction expository texts. So a lot of other ways you can explore the other natural disasters. And so these are all in the notebook that they can see, and there are real images. This is a hurricane from space, a hurricane on land. You can have them explore that. And I love how Diana reminded us all that NGSS is one of those things that really does just build on each other. So I know, and I can be guilty of saying it too. Like when we first were shown the NJSS standards, it's like, what? Wait, are we watering everything down? Because like they only have to learn this. And before we learn this, and it really isn't that. They're creating that natural progression of learning. The same as when you have a young toddler or a young baby, you don't just throw them the dictionary and say, learn all these words. We start just exposing them to what they see and what they know. And then you teach them the bigger words as they keep growing. And so it really is a K through 12 and beyond standards of learning. And I think that's why I have a passion for it myself, like with the second grade or third or fourth. It's so important to keep science in the conversation, because when you move into, let's say, third grade and they're trying to extend that knowledge, if we missed it in second grade or first grade or kinder, you're trying to make up knowledge and it's just not as impactful and their learning isn't as strong. So again, that's just my little speech, like don't throw out science, because I know sometimes it gets really hard when we're nervous about reading levels and things like that. Like it's really nice to integrate it the best you can. Investigation 4 is just, again, talking about those fast versus slow. So natural disasters and what can you learn from them? And I love too that Diana addressed that some of this can be frightening, and you just need to address that because it's real life and it's happening in the world. And, you know, we can be aware of things that are scary, but be also, the more knowledge can also give us some power in that as well. So there's some videos in here about disasters. And that takes us into investigation 5. So I know we have been on here for about an hour and 15 minutes. How are you guys feeling? And this is where I do want some feedback. So I'm going to put my gallery view back up. And Diana, you give me too, because I'm telling you, we can take a 15-minute break right now and let you guys stretch, get around the room. Does that sound like a great idea? Are you guys feeling like you want to power it? Let's take a 15. Okay, I got 2 thumbs and that's happy. Okay, so it's 9:45. We'll come back at 10 and we'll jump in. We only have 3 more investigations. So we might even get you done a little bit early for your Saturday. So go take that 15, grab some more coffee, take a stretch break. We'll see you in 15.
Okay, so.
Hey, we're back. And I can see Lauren is working on stickers for the kits. So those are pretty cute, Lauren. I like them. All right, thanks for that timer. I hope you guys had a great break. And I got some more coffee.
You can go ahead and I'm going to stop sharing. And then all right, welcome back. Ladies. Hi, you guys.
Hey. Yeah, no, for sure. I'll grab it back. Okay. So welcome back. I hope you guys had a good break again. Like I just mentioned, maybe walked around, got some coffee, used the restroom, talked about what's for dinner. I'm just really catching you up on what I did during the break. All right. So I'm going to jump right back in. Again, I want to be really mindful of everybody's time. So don't feel rushed if you're still, filling that coffee cup or things like that. Come back when you can, or, again, we want you guys to feel super comfortable. If your camera's off, like that's totally fine. If you feel comfortable chatting in the chat box, or if you want to just unmute and ask a question, feel free at any time. It's totally casual. Okay, so we're going to hop back into investigation number 5, exploring the phenomena of erosion. So if you remember, we've already talked about weathering, and that's that big, gosh, I don't know. I just remember 5th grade, like, no, weathering's not erosion. Erosion's not weathering. What's the big difference? And having to kind of have that conversation again and again. So we address them really separately in this unit where it comes a little bit later. And we've already talked about weathering, on how we saw how things were changed, how things kind of were once whole and then they became smaller, and they did that with their rock investigation. And so now we're going to look at what is erosion, and they're going to see the same thing by looking at an investigation around them. Now, we've done this before with in person, like when you're at school, and you can still do this even with a hybrid model, or even if they're at home with distance learning. It's just to kind of take that little field trip, walk around and look and see, like, hey, how do you think that got there? Again, you're not introducing the vocabulary yet. You're just asking questions. What do you notice? What do you wonder? You're being a real scientist. And I love talking to kids about this. I'm like, humans are the ones who put names on all of this. Humans are the ones who investigated to discover and come up with answers. And you're a human too. So, and ideas change. And so being an investigator, being a learner is totally something that you're able to do. And this is always a really good one. Science is, I think, a really great place for your students that are quiet or maybe not feeling as confident as readers or in math, that this is where they can really come out, because again, there's no wrong answer when you say, I see this, I wonder that. So really, really promote that thinking. So this is your teacher page that's going to kind of walk you through what we're doing. But again, the notebook's set up that it also walks you through what's happening. So even if you skip the teacher pages and you read it, the physical science or science notebook that we have, you'll start seeing that you could probably figure out the lesson on your own. So here it comes with the idea of what do scientists do? How do you act like a scientist? And scientists notice that some things have the same or share common characteristics. So we want to say, what do you look at that you see as the same? And for all of you out there, you're like, hey, that is a language arts lesson that we do. That is a math lesson that we do. So again, finding those patterns, we're seeing it again in science. So easy ways to integrate these science practices. So looking at pictures and images, and they're all real life images. They're not drawings or illustrations. So you can see that this is how the world really works. This is the earth. And what did you notice that changed? What do you think caused that change? And what evidence do you see? So coming back to my favorite word, because, like, I see that this looks like it is broken. I think that it fell because I can see pieces down here, and that's natural thinking. So pushing that higher critical thinking is so big. I know with my second graders, sometimes they'll just want to write rocks. And you got to say, nope. And you really want to push them back. And if we can start that habit, that practice now, it's going to really help them as they grow. And it really just defends their thinking and their learning. And again, you'll use this in your language arts where you're saying like, how do you know that in the text? And it's like, I found that in the text, the evidence from the text states. It's all that same practice of backing up your thinking with evidence that you see. So this goes through, this is all digital notebook work. It's not anything hands-on on this part, meaning that there's not a hands-on experiment for investigation 5. It's more taking that time to have a virtual look around. Something you can do if you want to add addition to this is you could do like a virtual field trip with like the California State Parks. They have a lot of things on erosion where you'll actually talk to a park ranger. I don't know if any of you guys did that, have done those. So fun. I would totally recommend it. You just go to California State Parks. They do them, I think, gosh, they were doing them 5 days a week. I think they still are. And they modify it per grade level. And it's a park ranger. They're usually adorable 20-something people who are so happy about the world and life. And they will take you through things like Santa Cruz. They take you through the arches at Santa Cruz and explain how did that happen? And it's all directed towards second grade. And it's a schedule where all you do is sign up. So that's a really fun extra way to kind of show like, this is your world. And again, kids probably have been to Santa Cruz. So they're like, hey, I know that. Or looking at these pictures here, we have cliffs just like that in Orange County. So, well, hopefully not this one where it's falling. So looking at what do you cause, what changed it? So it's the same thing. Everything's an investigation. You can see the E we're looking at is explore. So we're just exploring the world around us, being those scientists practicing what is the same. And they're going to start saying like, wow, I think something has changed, something else in every single one of these pictures. So things weren't the way they were before. Something's changed. If it was whole, it's now not so whole. The conclusion that we're hoping that we're going to be able to get with all of those patterns, with all of those looks, and I'll show it to you again one more time, is what's something that you see in each of those that could cause some of that change. And it's water. How did the water break down these cliffs? How did the water break down these, what do they call them? Oh gosh, what do they call? Sea stacks. That's what they're called. And I only know that because I went to Oregon. And the canyon. So all of this has water in common. And so if they didn't get there on their own, you can lead them there. You can be like, hey, let's look back and see what do we see the same. And it comes to that conclusion is what helped make that change. And the answer is water. Water is definitely a very powerful element that helps wear down Earth's surfaces, and it helps move those pieces elsewhere. And so if you guys are picking up, I just gave you the definition of erosion. And what does it mean to erode? Move something elsewhere, usually done by water, but we haven't even given them the word yet, but we will. So that takes us to investigation number 6. So this investigation is with sand and a squirt bottle, and they're going to love this one because it's a squirt bottle. It's basically like a squirt gun. And again, those model houses that we've been using in the volcano one, and the digital notebook. And if you want to, we also have some printable handouts as well that we linked. So these are all Google links to the handouts, where if you're would rather have them do that on pen and paper and then either take a photo and upload it to their notebook or submit that, you have that option as well, or you can keep it completely digital. So we're going to, there's always like a little talk about it before you start. You can have them investigate what their materials are and what they're using. So the students are going to place a cup of sand in a paint tray. And so this is that build a sandcastle kind of moment where you'll give them a cup, and they'll be able to touch it and feel it. Again, we're going to provide this for you. So your kits are going to be heavy because you're going to have enough sand for 30 kids. And you can make a chart paper for this, again, any way that it works for you. But you want to talk about how that sound feels and how it moves. And sand's a really easy one because we know it crumbles and moves pretty easy. But you want them to kind of think about what do they see and how does it work. So it might be, how does it feel? It feels rough and powdery. It's a little chunky. It moves. When I squish it, it seems like it gets harder, or I can sprinkle it everywhere. There's, again, no wrong answers, and it's a really good speaking and listening. So I'm going to stop sharing, and I'm going to let Diana show you, oh, one more, sorry, properties of water. So that's the other piece. We're using the sand, and then as well, how are we going to get that sand to move? We're going to move it with water, just like we do with erosion. And your squirt bottles that you're going to get 30 squirt bottles for all of your kids. And they have that ability to change from a stream and a squirt. So we're going to have to, or a spray. So you're going to have to experiment a little bit with that and let them figure out how to get the different streams. But you're also going to say, how does that feel? What's the difference that you feel? And like the stream will obviously be a little bit more targeted, a little harder, while a spray might feel a little bit more light and misty. And then making a prediction. What am I going to, how do you think my sand might change if I apply this water? So investigation 6 is all about getting recreating a real world event. And so you're going to pack the sand in a cup and put it in a tray. And this is where I'll stop sharing right now so I can kind of give Diana's picture a lot bigger. And you can see how to run this one. Okay, Diana, you're all set. You can make your castle.
Okay, so basically you just take a little Dixie cup. For the sand, it will probably be dry when you get it. So what I encourage you to do is you can use the spray bottle or just add a little bit of water and tell the kids to add a little bit of water to it so it sticks together. Otherwise it won't work. And so you just quickly put the cup, turn the cup over, and then you have your little sand castle. And then on the spray bottle, the knobs, you just twist the knob to make, I think you all know, to make it either mist or stream. So the first time, and Liz, do you mind showing the notebook so they can see? In addition, the first thing you're going to do is mist, I believe, 3 times. Yeah, spray the sand 3 times. Whoops, so that's a stream. Put more in this. Okay, 3 times and watch what happens. So again, they can either post a picture or a drawing, or next time you're together, you can share your drawings. And what do they notice? And they probably won't notice much here. This is just to kind of show how erosion happens over time. And then if you, now 30 times. So now they're going to do it for 30 times. And they're going to start seeing that the sand is going to start coming apart and falling down, and we don't have to do all 30, but you'll start seeing the sand falling apart, and that's where the erosion starts.
So then you're probably going to get that, my hands are tired, and you want that. You want them to be complaining about 30 times, because the whole idea is this does not happen quickly. It's going to take a really long time to change that sand.
Right. Right. That's very true, Liz. They will complain, and at first they'll fight over it, because if they're in the lab together, they'll all want to spray each other and spray the sand and all of that. So, but then after a while, just like the shaking the rock for 10 minutes, after 2 minutes, they're going to say, I'm tired of shaking. Well, no, you got to do 10 minutes. So they'll learn how, it takes work. It takes energy to make those changes. So then we spray it, and then now we're going to do it again. And now you're going to use the spray. So you're going to make it, just twist it, and you're going to, you can see how the stream really, can you see it or not?
Let me stop sharing, because that's a big difference. So you're repeating the experiment, like it's a whole brand new experiment. So this is where you can address that idea of an independent variable. What's the thing you change? And you can see like what a big difference.
So I'm just streaming it now, and you can see how fast it's just melting. Okay. And oh, I forgot to put the little houses on there, but they would see how the little houses,
I think you're supposed to put the houses on the mountain.
On the mountain, I'm sorry.
Yeah, no. It models the phenomena. Yeah. So where you can see that house breaking off and falling in.
Right. So I forgot to put the little houses on top. Sorry about that. So then you'll just see how it erodes, and you can actually see how the water is moving the sand.
Yeah. I love it. Okay, let me
Very
hop back.
simple.
Yeah, it's actually a really simple, easy, not too messy. So I don't think you're going to have a lot of parents complaining about, like being at home with it. And we're going to provide you those aluminum trays too that are going to be there for their multiple experiments. And those trays are great. I don't know if you guys use them in the classroom, but they're reusable. You just rinse them out and reuse them again next year. So it's definitely a good one.
Mm-hmm.
So talking about that independent variable, and you can use that word. That's the one thing I really feel like with science and all academic areas, really like use the big vocabulary. Don't wait and be like, well, you have to be 10 to understand this. No, just start using what it really is. They'll pick it up. And it's really good when you share things like, this is the independent variable. This is what we're going to change. And then it might stick. And you've got 3 or 4 kids that when they hear it again and they are expected to start using it, that they're going to remember that second grade moment when you guys shared it. So again, spraying the sand 3 times, reporting their observations. It's the exact, very, very similar as the spray versus the stream activity, just with the one change. There's notes on here, like don't throw your supplies away. Place your sand in the sun to dry, because you're going to need that sand again for our end of the unit engineering challenge. So there's notes on what to keep and what not. And I'm in present view right now, but if I was in like grid view where you can see the whole slide deck, you'll see notes on the side as well that will mention what you need and what to keep at the end. So the students will see that too when they're going through it. Finally, the conclusion, did the water change your sand map? And yes, like, they're going to say, yes, it did. Explain, use my favorite word, because it did move. Why did it move? Because the pressure of the water or the water made it move. Again, we're defining erosion. They're doing it. We just haven't told them it's erosion yet. So let's see. Okay. So that goes to the E with explain. So now that they've talked about how water makes that sand move, how water's moving, we're going to take some time to say, well, this is erosion, water moving rocks and minerals and changing the shape of the land. And so there's a little video on what is erosion. And then it has a moment where it's like, you tell me what is erosion, you define it. And that's that language, if you can explain it, you can teach it, you own it. So this is their moment to learn a little bit more. You can explain it to them. Again, this is where you would interrupt. So if they're like, erosion is, I don't know, a snowman that comes alive, you're like, whoa, not a good explanation. Or if they say something like erosion wears things down, like that is where you are going to be as a teacher, and you're going to step in and you're going to say, actually, no, like erosion is the movement of the item. So it's like you really want to make sure you're clarifying and jumping in and clearing up any misconceptions that they might come up with. And again, they might have that confusion with weathering, and we want to help we want to help clarify it and make sure that they know that while they're very similar, they're not the same. They're different, and how they break things down and how they move things. Okay, this, I'm not a singer. I wish I was. I wish I had the rhythm and the talent. So when my kids get music in my classroom, it's not usually very well done. So it's memorable, but it's not well done. But if you are a singer and you have that, I love to add the music or the songs to the learning. This was a little chant that we found. I think it's courtesy of Santa Ana Unified, but they wrote it. And it's sung to Row, Row Your Boat. I'm not going to ruin your guys' morning with my attempt to even try and match that up, because I'm telling you, I'm not bad. I'd be like, row, row. I don't got it. It's bad. So if you want to add a song, there's tons out there. You can do YouTube and things like that too to kind of work on those as well. Okay. So remember we started with that anchoring phenomena where we first watched that video with the drone looking over the cliffs. So you can come back to that multiple times throughout these lessons, but this is definitely a time where we want to revisit that phenomena and you want to show it again. And this is where the notebook is so powerful, because they have those day ones, those investigation 1 notes on what did they notice, what did they wonder, and now going back and rereading them again, going back and looking at their wonder questions or their notice questions. That's when the learning's really going to hit home. And so that's it's just the whole scientific proves, like if you come to that answer on your own, it's so much stronger and so much more impactful for them. So going back on that learning, reflecting on what did you really see, how do you explain it, is the powerful learning moment. And we're getting there by investigation 7. So you replay the investigation phenomenon, the anchor phenomenon that we played in the beginning. And now you don't ask, what do you notice or wonder? You're going to say, what do you know? What do you know happened in this picture? And you're going to get those huge vocabulary words that you had. The erosion, the weathering, the landform, the cliff, the coast, the ocean, the body of water. All of those words are going to start coming in here. You can support your learners with a vocabulary chart if you want at this point too. What do you think, Diana? Is there something more you want to add to that one?
No, I think just revisiting it and seeing their growth and using that academic language. And a lot of times I'll put a word wall. I'll put the words that we're learning up on the wall, and I'll encourage them to use those words that are posted. You can just put it on tag strips or whatever. Also, the nice thing about this notebook is if you have Google Classroom, each student, you can just push it out. Each student has their own copy. And, or I think with Seesaw, you can do that too. So it's nice that they can always go back and see how far they've learned. So.
No, definitely. I think like in Schoology, you can push it out just like that if you're using that. I don't know. Everybody's got a different course we're writing right now. But definitely that's the advantage, I think, of pushing out the whole notebook at once instead of putting out just different slides. But again, you can modify this to what works best for your kids. Sometimes it's overwhelming to have them see all 8 activities at once, or you get that kid who jumps ahead without you, and you want to slow it down. You want to have them go through the steps with you. So investigation number 7. So now that they understand from that anchoring phenomenon and all of the learning that we have, we want them to explore other forms of erosion around the world and how things can, how it all kind of comes together. So this is our second to last lesson. So this is that moment where it's like, look at natural disasters. Look at these arches that are formed in like the canyons. Are they fast? Are they slow? Did they cause change? What landform do you see? And this is that ultimate coming together. And this is again where we really integrate our learning, because it's reading and exploring, and multiple resources as well. So I recommended on here Epic, which I don't know if you guys use Epic. It's free during classroom hours for classroom teachers, and you just push out book collections, and they are able to access these book collections during distance learning. Epic makes their money on having kids subscribe. So if I was a student in my class and I wanted to access Epic, I think it's $5 a month, and I can access Epic at any time. I can access it for free during school hours from like 8 to 3. What Epic did this year with distance learning, which was pretty cool actually of them, is that if you, I don't know, I guess if you sold your information and hooked it into a parent account, meaning that if a parent registers the account just by giving their information, their email address, and their check that it's okay, the Epic becomes available for, I think it's 2 hours or 4 hours after those school hours. So if you have that kid who wants to read a book at 5 o'clock, it gives them like, a timing. So that's free right now. That's a distance learning thing. I don't work for Epic. I'm not trying to promote their product in sense of like, I get a kickback, but I have to say Epic really, really is one of those very student friendly. They have videos as well as read alouds, as well as access to tons of books. And it's a lot of really good books, nonfiction and fiction, titles that your kids will recognize, and it's an exciting way to learn. So I don't know if you guys are familiar with that program, but it's something I recommend. I use it a lot. Showing more videos in class, like you can explore videos. Hopping into songs again. There's a Let It Go parody, which this one is done by a dad. I have to show you guys like 5 minutes of it, or not 5 minutes, 5 seconds of it. It's a dad who did it, and he clearly has his kids involved, and it's kind of ridiculous, but it would hit the second grade audience. He made it like 4 years ago, so it's got like what probably was cool in video making back then too, with like, look, I'm making her head fly, because it just gets awkward and weird. But
There's jagged peaks on the mountain today, rough and rocky terrain. If we wait here long enough, nothing will stay the same.
here's his son, but I don't know why.
Bring the mountains here and there. Nothing can never stop it, and the earth don't seem to care. There's many reasons for weathering. Stuff hits the rock, cause fracture rain. To silt and sand, where will it go? Will we ever know? Rivers flow.
Okay, so I'll let you watch that on your own. I know you guys are willing to subscribe right there. Oops. It's just kind of cute, and you've got those kids that are going to love Frozen and will connect with that, and you can even have them do it. But bringing, again, music into the learning. This is really cool. Looking at cracks, like evidence of land cracks. And I've never done this. I don't know if you guys have ever seen it. And I love this idea. It's going outside in nature, and your sidewalk counts, but finding those cracks in nature and turning them into art. So it's that whole like line design. And so you could do this one day as an outside activity. It could be something they can go do. It's easy to implement during distance learning, but it brings that art element into the science where they're finding how things changed. And so there's some, it's sidewalk crack art. And there's a girl here, and I think it's around 16 minutes long, but she'll explain how you can go out and find that. So you could do this. This could definitely be an asynchronous after school or after class activity. Okay. So big thing, scientists determine relationships between events. What happened and why those events occurred. And again, that curriculum integration, cause and effect, we teach it all the time in language arts. Here it is in science. Those same exact lessons, like, you know, so, because, due to. And so teaching those academic language in there, using that cause and effect, and it'll help form that conclusion at the end as they're becoming the experts on what is erosion. So there's a cause and effect chart. And you can do this, again, there is a chart, a printable, that you have access to as well. So if you're like, I don't like the digital idea, I'd rather do it on pen and paper, you're more than welcome to. It doesn't even have to be formal. If you're familiar with like thinking maps and things like that, you could use a flow map idea and just have them start writing it down on paper. But what I liked about this one is that you can fill in the missing cause and effect, providing samples from their work that they've been looking at. So this is the sample page where they would see, like, here's my cliff, and the cause was the waves in the water from the ocean below crashed on the cliff over a long period of time. Then the effect was the cliff eroded and fell and the house was no longer safe. So we're using that language again, like the cause and effect. The cause was this, the effect was that. So there's pages in their notebook where they can fill in these exact ideas. And let me see, when the students see it, they see the slide deck like this. So they're taking those images that they've already been exploring in their old throughout the unit. So if I wanted to do, let's just say, wildfires, I could put the wildfire here, and I could say the cause is there was a wildfire that spread quickly. The effect was it damaged and destroyed the trees. They are no longer there. So you can, they drag and drop these images. And again, they're all the images we've already seen and that they're familiar with. So it's not like they're having to go source them or anything like that. And we've already had discussions with them. They know what they are. So it's a nice little check-in. And this is, again, when you look at the E that we're looking at, this is the evaluate. Did they learn what we've been hoping for them to pick up throughout the unit? Okay. So there's a couple of pages. We did 3, shrinkage 3. I'm sure you guys have probably heard the CER, the claim evidence reasoning argument. I know, like, even middle schoolers, like, that's how they, it's the lingo, like, oh, did you write your CERs? And they have to say, and so again, start practicing it early. What's the claim that you're going to make? I'm going to claim, why does land change? My evidence is, what do I No. How do I know that the land changed? The land changed because my evidence is. So that's a good little thing. You can talk it out. It could be something you could do as a writing. You could make it, but you're using everything that you've gathered, all of your investigations, all of the readings, everything we've talked about, your videos, your extra notes. So this is that culminating check-in. Do you understand the standards for Earth and Science Unit? Okay, so again, a little moment right there for them to state their claim, reminding them that that's how scientists really do base their learnings. This is how we get changes, and we're watching this every day. How scientists are figuring out things, and it might be right today that they change their mind on tomorrow. It's okay. Base it on what you know. Last one, our investigation 7. We're almost done, I promise you guys, and we're actually a lot early. So I hope that gives you a little smile inside too, because you're getting some Saturday. But understanding that scientists categorize and classify what they observe, changes on Earth can be fast or slow. And then thinking about all that you learned, sort the events. So again, this is another one where it's a drag and drop. And you just, the topics are on the outside. So they would just sort like, this is a fast change, waves crashing against a cliff. Do we think that's fast or slow? That would be a slow one, but a wildfire would be fast. And if, again, you're like not really loving the drag and drop, they can recreate this with a T-chart very simply onto their papers, and you can always do it that way. This is everything that's on here are things that we learned about and talked about. Nothing is like I didn't throw in a new natural disaster that they hadn't addressed. So it should feel really comfortable and confident in when they're doing these sorts. Okay, so the last one is our engineer design challenge. So were you going to model this one, Diana?
Yes, I was. I am.
Okay, so I'll show the present screen, the teacher note. This hits your engineering challenges, which are part of our NGSS. Oops, I pushed the wrong button.
So this is where they'll need to, those things that we ask them to save, this is where they'll use it. This is our last activity. So again, they can reuse the sand, the aluminum tray, popsicle stick, the plants, houses, water, spray bottle, rocks, cup with the lid, sand, and paper straws. And we go through, you can either break it down and do one step every day, or you can make it a whole lesson depending on your time frame. And again, this is something they can do at home and then post pictures of it. So if you want to go ahead, and here's your challenge. The town of Sandy Cliffs is concerned about how waves are eroding the cliffs. They have asked you to design and build a barrier to protect the town. So I will show, okay, and here's the materials, the constraints. So you may only use the supplies provided. And I usually talk about how engineers have constraints and criteria. Usually it needs to be low cost and you need to do it in 2 days or whatever, or the constraints, they don't have unlimited resources and time. So we talk about how engineers have to work within those. So the first step is to create a steep cliff, and I will show you my, here's my little cliff. And I'll try to show it this way. Let's see, I need to pick it up a little bit, but I put my little house on there. And again, the whole trick is making sure the sand is at least damp, not too moist where it won't stick together, but you want it doesn't have to be perfect. Sometimes, like, my sand got a little damp, so I just put a paper towel on it and it dried it up pretty quick. But you want it to just build a cliff. And I've seen this done in aluminum trays. I've seen it in paint trays. You can use all different types of things. But for second grade, we're just introducing, it's a first step. Just make it easy for you and easy for the kids. And so now they've got some straws. So let's say they want to put some straws here because they want to save their little house. And they might want to use some of the gravel that we were using before and the big rocks. And so they're putting those up to save the sand. I've got my little popsicle stick that I can help pat it down and things like that. So you can kind of get the idea of, and again, the kids will love doing this. If I was at school, I would probably, again, do it outside. Just anytime I do sand or explosions or anything, I go to the lunch tables or on the grass just so that it's less cleanup for you. So the next step, Elizabeth, can you show the notebook? I think it's spray with the water bottle first.
I will. I'm just replying to Christy Kaufman, who said that they're at the Dollar Tree, and I love the Dollar Tree.
Yes.
They have so much good stuff, things that you don't even really know that they have. So always go on their website too. But remember, we're also providing you guys with these trays, so you don't have to go buy any. So,
and they're in individual packets, so you can just give them the packet and go for most everything. So it's we're really thankful for Kids at Science making it so easy for you. So there's a little picture of the design process. You ask questions, imagine, plan, create, improve, and present.
Yeah, so I'm sure you guys are familiar with the design process, and the kids are becoming more and more familiar with it as STEM projects, sorry, I'm not in present mode, as STEM projects have become more popular, and kids love to skip these 3 steps. They just want to create. So, but it's so important to have them do these, ask questions, make sure you understand what your design is supposed to be, imagine and think and plan, and then you get to come to this part. So a lot of times with these STEM projects that I see, and I love that kids are doing them, but teachers focus just on the create, where it's like, you have 15 minutes, create it. And it's really not the, it's fun, but it really doesn't take them through this whole thinking process. The other one that gets skipped a lot is the improve. How would you fix it and make it better?
Right.
Because engineers are always fixing it. So the notebook takes you through it. Go ahead, Diana.
Oh, I'm sorry. Yeah, definitely. Oh, good. You broke it down here first. So they can type in what their questions are. And a lot of times before we even start, I'll let them look at the materials, what will be available. But when they plan, that's when they need to just draw on a piece of paper, draw your ideas and share your ideas. So there's your questions.
Yeah.
And then this is where you could draw.
Yeah, I was just gonna say, you can change this. Like, sometimes when it's like, use popsicle sticks, and you're like, I don't want to give my kids popsicle sticks. I'm not feeling it. Change it. It's no big deal. Yeah, use whatever it is that works for you. Yep,
you can definitely change. Sometimes when I'm low on tape, guess what? We're only getting 6 inches of tape today, you guys. so that's a nice thing about having the criteria and constraints, and it's amazing what they come up with. It's almost like the fewer things they have, the more creative they are. So keep that in mind. So here's the plan. So here's the important part for them to draw. They're going to draw their plan here, and make sure you label the parts, what kind of barriers they are, or if they're going to have a rock pile or whatever.
And remember, they have all those materials, but they don't have to use all those materials. So you want to remind them too that they're going to have to decide what materials work best for their idea. And so there's a lot of critical thinking in this, as well as creative.
Right. So work carefully and watch your time. Remember to keep your goals in mind. And so this is where they're going to follow their plan and create it. And then they'll take a picture of it and label the parts. Or draw a picture, and when you all get together, you can see their picture. Step 5, type the test to see if it's successful. So this is where you're going to get the spray bottle again, and you're going to put it on stream, not mist, and you're going to spray towards your cliff 30 times. Did your barrier protect the cliffs? Keep trying. How many sprays will it take to knock down your cliffs? So they'll really like that. So I'll put it on spray. I start spraying it.
Yeah, because let me see. And you might want to set up some more rules or constraints for this too, like how far away your spray bottle has to be. How many times up to, but you see with Diana's model, like it will collapse. And that's the idea, because that cliffs are going to collapse eventually all over.
Mhm.
But
Now, there's
so we can see the
one
number.
other part of this before mine collapse altogether is you're supposed to take a cup and poke holes in the lid and make like a little water bucket, and then you pour it over um, for them to really see. Can you see it, or was my hand in the way? Shoot. But when you pour, it's like they call it like a watering can. You make a little watering can, and you pour the water, and then you can really see how that type of like if a hurricane or something came down really strong, how that would impact it. And then the nice thing about sand is they can always back it up and use their little popsicle stick to move the sand. But what was it that they needed to do after?
They're going to improve it. So that's where, and they'll want to improve it. That's where this is really fun, is looking at the difference between how fast it got destroyed. And it is quick. Like they just spent a lot of time building their little design, and now it's broken. And that
Right.
gets back on that design idea of reiterate, go back and improve your design. And then finally, we want to share it with everyone. And this is like where you can decide how long you want to spend on this, because kids could spend a very long time talking about this and showing it off to each other. And one thing that we get very competitive with, which is like, don't steal my idea. But the idea is better if we share our ideas. And like, I saw yours and I took a little bit of your idea and your idea. So you can choose as a teacher to, you could have them share during a meet, or you could have them do a flip grid or a Padlet or something where they're sharing all of their ideas, and let them see it and go ahead and steal ideas from each other, borrow somebody else's idea and build it yourself if you think that's a great idea, and have it work. We're not patenting. I don't even know. We're not creating patents on how to build these clip things. We're learning from each other, which is what engineers and scientists do. So
Yeah,
here's an extra test. I don't think you brought your hairdryer for this one, Diana, but you can do the same idea, but with air and move. And then that was the watering can that Diana showed you as well.
oh, yeah.
The hairdryer obviously would be an adult friendly use. Don't have them mixing the water and the electrical on their own. Or they could do a fan in their room type thing, or even just a fan with paper. You can modify that. But I hope you guys see how, like, through this like hands-on investigation, that what we're doing is they're really modeling, you know, exactly what Diana said, like hurricanes, rainstorms, high waves, winds, those things that do change the world, and they're creating it themselves, which is a lot of fun. Okay, so going through the improving process, how could it get better? And like I said, you could copy and paste the slide 10 times and have them do it. It just depends how much time you want to work on it yourself. And sharing that idea, which we talked about, and there's lots of ways that you can do it, lots of platforms, whether it be Seesaw or Padlet or something, Google Classroom. And then making that conclusion, write about your barrier, how well did it work? So again, we're writing, so we're using that to explain it. What did you learn about, what would you do differently? What did you learn about it? Can humans actually stop the earth from changing? And that's a really powerful question. And, you know, all these people with beachfront property are going to say, yes, I hope so. But you know, when it really happens, that there's a lot of things we can't control, even if we want to. And oh, gosh, I think this year has really kind of hammered that in. Like, we want to control that, but humans aren't as powerful as we think. So it's a really good reflection time, great discussions. Again, like, landforms are not my favorite. And I don't know if I should say that to you guys, but like, I always feel like, oh, you know, we're going to talk about mountains. But you really can get into some really awesome activities and conversations, and kids love rocks, which Diana, I know, oh, let me adjust this too really quick. California principles. So part of our NGSS, and it's not new, but it's part of California's standards. And Diana, I'm going to mess it up. Was it just released like 3 years ago? Or the California principles?
2016.
Okay.
With our framework. This is what makes us different from the national NGSS, is California created these environmental principles. And so this is when you start looking at curriculum developers were asked, if you're doing anything in California, you need to incorporate these principles. So landform in our unit, we do look at the human practices can alter cycles and processes and operate within the natural system. So concept C. And there's 5 principles in there in the framework, and you can find a lot of information about them.
Yeah. And it's actually really easy. It's almost like when, I don't know, this reminded me like with the 98 standards where you wanted to teach some lesson and you could just find a standard that would work for it. The California environmental principles, they're very much like naturally part of things that we look at. Like, again, like, do humans change the world? Yes, you know. So just a little feedback for you guys, or I don't know, I think I even addressed it, is that we have a bunch of blank slides that are on here. So when you guys go to access your materials, you're going to get the exact presentation we just shared today with the yellow teacher slides to walk you through, but you're also going to get a copy that is that one you can push out to your students. And we put just extra slides that have the format with a notebook in the behind it, so that if you want to insert your own pictures, your own activities, anything like that. Again, we want you to modify and change this and make it work for you. If you come up with something super awesome, share it with us. We would love to include it. We all learn from each other, and we can always improve, like we just talked about with engineering classes. So that concludes our presentation. Do you guys have any comments or questions? Anything you guys want to share? It's okay. It's Saturday morning. I totally get it.
And I also wanted to share before you go, I did have Kids at Science give you a little rock collection. I'm so excited. Liz doesn't understand. I get really excited about rocks.
Yeah, like, this is where Diana and I am like, rocks, like, they're cool, but I'm good. And Diana's like, woo-hoo.
They're so fun. So you'll get a little rock collection of like 15 different ones of the sedimentary, the igneous, and the metamorphic. So I wanted to make sure you saw pumice. Pumice is the one question I always like to ask students is, do all rocks sink in water? And they'll say, oh yeah, they sink, but pumice doesn't sink. And so whenever I show them this in water, can you see it there? See, it's floating. They're like, oh my gosh, what is that? That's not a real rock. That's not real. And I'm like, yes, it is a real rock. And we talk about how it's has little holes in it, which allows it to float. And so we come to the understanding that no, not all rocks sink. So that's a fun one that you might want to show your kiddos. This is, you'll have a couple sandstone. Sandstone is what we have around here on our cliffs, and it's the layering. So this is where we find the fossils. And what's nice about the rocks is letting the kids hold them and feel them and touch them and see how heavy they are, and the texture and the colors. And some are sparkly and some are not. So I hope it kind of gets you excited a little bit about rocks. But there's sandstone, we've got basalt, which you probably see around here. This is our igneous rock, and then obsidian. A lot of my students love the obsidian because it's shiny metamorphic rock and it's black. So I just kind of wanted to show you, they're much more exciting in person, trust me. But you'll get a little rock collection in your kit, and that is why it's not part of a particular lesson, but just to kind of get you interested in rocks and minerals. And then hopefully when you're back in person with your students, or if you are, you can just kind of show some of the rocks and let them choose their favorites. I always say they're special rocks, so no throwing, no breaking, no, you know, hold them very gentle, just like an animal or something, because you want them to last a while. But it's just something that will be in your kit for you.
Yeah. And if you guys attended our physical science presentation, or that unit, which I think they'll have access to as well, right? On the site that we're going to share with you in 1 minute. Yes. we use the pumice. It's a whole lesson with physical science, like, you know, what the difference between the density and floating and sinking, physical characteristics, observable physical properties, observable physical properties. All right, so I'm going to show you guys how to get to our website. And when you're there, you are going to be asked to fill out an evaluation. And that evaluation is going to take you to, when you give your information for there, that's how we're going to contact you to get your free science kit. And we're hoping, I believe, Lauren, that March, we're going to bring those kits. They've been ordered for a couple months now, but with COVID and everything, like things are coming in, trickling in, but we'll let you know when they're available. Our arrival date that we're hoping for is somewhere in March.
Also, due to the restriction of that non-essential workplaces, we can't open for indoors. So the crew assembling it, we're farming them out to people's homes, you know, they're bagging things for you. So the worst case scenario is this, you will get a 50-pound bag of soil. And I think some units have soil, sand, and different types of, we might ask for you to bag your 30, you know, whatever, how many student, but we will provide all the materials needed. In the past, we've done individualized kits for every kid. But as we're moving forward with COVID being closed, a lot of things are shut down. We, to meet our March, the beginning of March, that's when we're aiming to get these kits out to you. Just know that some of them you might have to bag your own for your students, okay? It's just what we have to deal with COVID right now. We try to do it as best as we can to put in individualized bag for your students. But worst case scenario, like you might get a 50-pound bag of sand. And it's not so bad that you do it for 30 kids, but 30 kids times 20 kids, that's 600 baggies that we have to do. So please understand that. I hope that's okay. All right, we'll do our best to get as much to you, one sample teacher kit of what the student kits look like. But to meet our deadlines, to get these out into your hands so that you can get these out to your students, you might need to get a volunteer or yourself. Bagging 30 bags is not as bad as for us to do about 3,000 bags, you know, or across the board. All right.
And Lauren, just to clarify, we provide the bags and everything too. So
absolutely, absolutely. And it's labeled for you 1 through 30. And then if there's additional bags needed for other items, you will be provided for those as well. Okay.
Okay. So if you go to the kidsatscience.org website, you click on NGSS Units 2nd Grade DL. It's gonna ask you for a password. Your password is NGSS 2020. When you enter that, you're gonna see the units that we just talked about today. So here's the 2nd grade Earth Science unit that you saw the presentation with the yellow slides. This is the 2nd grade, this is the yellow slide one. This is the one below it that'll show you the student notebook. And you'll know the difference when you click it because one will force you to make a copy and the other one's view only. There's that physical science one, which we built with the same model. So it's the same kind of notebook format. So your students, if you want to hop into that physical science, please do it. We'd love for you guys to check out that unit as well and give us some feedback on that. Here today is where your workshop evaluation is. So you're going to click that and it's going to take you to a Google form. And we really do appreciate your support. You guys, I saw your comments coming up while Diana was still sharing about the cool rocks. And you guys are so sweet. And like, honestly, like it's a little nerve-wracking to come up in front of your peers because like I'm doing this with you and Diana too, like we're teaching in the classroom. We don't exactly consider ourselves experts. So to hear your feedback of like, this looks like something I can do, or I'm excited to do it, it just really makes feel good, heart swell. Definitely thank you so much for that support and feedback. And so you want to fill that out, we'll contact you in March and have fun with science. And I think that's it.
Can you repeat the guest password? I put it in and it didn't seem to be working.
Yeah. So, okay, if you don't go to the DL, you got to make sure you go to the 2nd grade DL. Don't go to like this one. And that's where the password will work. And it's NGSS 2020. All together, no spaces.
Yes, life science is coming up, I think in June.
Yeah.
And the physical we just did in November, we usually do that, but we will be training again next year and over the summer. So,
And
oh,
with
thank
every
you.
training, you get a kit. So I love that parting gift. Like, it's like, you get a kit, make sure you get that kit. It's
Yeah.
phenomenal. And I love the physical science kit. The life science kit is, it involves glitter, but we created that life science unit when distance learning had started. So that unit is actually very distance learning friendly off the bat, but it also will have a notebook. Everything will kind of format the same. So you'll be used to it. Your kids will be seeing that same outline.
Yes, and encourage your friends to join, to come to trainings. The more teachers, the more students will be learning science. So we appreciate your feedback and encourage other teachers to join us.
Okay, so when you go on our website, I just want to show you a live demo. I think you can see my screen, right? Yes?
Yeah.
So kidsatscience.org, when you see NGSS units like this, you click on it. And then these are modified units, DL for distant learning. So you're in second grade, you would go here. And then mine already has the password saved in. So you can do that too. NGSS 2020. And the physical science unit that we modify and we train on, these are it right here. The teacher units are here. And these are the student notebooks. The notebook, and then this is the earth science that you just attended. Here's the earth science unit. And then here's the student notebook. Please note that the student notebook, it will prompt for you to make a copy. So you're welcome to share these out if you're in Google Classroom, Seesaw, or break it apart or however you need to. All right, so you can make a copy that way. But the teacher's edition, so if we make changes and things like that, it is locked, okay? You cannot make a copy of the teacher edition. But the our two trainers, Diane and Liz, did a really good job integrating to the student notebook too. Okay, so you can actually, some of you can even teach off of the student notebook too, is that right? But you're missing the yellow slides, right? Which has more background information and things like that. But if you look at the student version of it, I want to show you. I'm going to make a copy. Okay, it's a lot of slides. It might take a little bit. Okay, but you can see it's designed so that it's ready to go, that you can share with your students. They embedded the videos in there. Okay, so you can do it synchronously or asynchronously. All right. So they've really modified it so it's easier and friendlier for during this time of hybrid and virtual learning. All right. So that is already on our website. So you have access to the physical science unit. So for those of you who didn't go and you think you can, use this, go ahead and do so. But the way we build our kits and give them out is after the training. We get a head count of how many, we build them for you, pick them up, share them with your students, pass them out. Now, please try not to hold on to these in terms of this. Use them, give them out to your students. Next time you come to a training, we're going to give you another kit. Does that make sense? So some teachers are like, I'm going to save this up so when we're back to normal. The whole purpose of this is that we want you to continue to do hands-on science during COVID, during this pandemic, because it's very sad. So many of our kids, they're just sitting, staring at, online. They're staring at that screen and they're bored, so give them something to do versus nothing. Try to get these out, all right? So use these lessons now. Don't feel like, oh my gosh, I'm going to save these up. Just know that we are, we just got the Beckman Foundation. They funded us now for another 5 years. We're not going away, okay? We're going to get you hands-on science going and going and going. So as much as possible, please, during this pandemic, share with your students, encourage them to learn and foster that love of curiosity and learning. So we really do appreciate that you're here. We value that so, so much because we know those dedicated teachers, doesn't matter, pandemic or not, it's not going to stop us. We want our kids to learn. We want them to learn in a hands-on approach. All right, so we thank you. Make sure you answer that survey for us. That is how I know to send out who came to the training. We give you the kits. Now, we've been contacted by people that says, can we just get the kit? We can't make it to training. We hold our bar that way because, as you know, sometimes you get things sent to you, but you haven't had a chance to look them over. We know that's not the most effective way. So encourage your friends, your colleagues, come to this training, you guys. You get the materials. We try to walk you lesson by lesson. So let's give a cheer to Diana and Liz, you guys. They did an amazing job, okay? Thank you so much. Teachers helping teachers. It's what more beauty that can you get? And Kids at Science, we will always do that. grade level, very specific. So when you get swapped to another grade level, sign up, look for Kids at Science. We will be posting our training. So our cycle has been kind of like in October, in January, in the summer. We will do 3 cycles throughout the years. Okay. So so please look out for it. Join our social media. If you're doing a lesson, if you're, take a snapshot, just give a shout out, Our funders, they do look at this. They're like, okay, we're glad. Their main purpose is teachers are using it, kids are learning, they're happy, we're happy. And so again, you're not going to find another organization that there's no full-time staff. I'm a full-time teacher in another district. Diana is too, Liz is too. It's an amazing organization. So get the word out for us. Our intent is get more teachers to do science with their kids. All right. With that, we're going to say goodbye. You are welcome to please, leave. Stay back if you have questions for us. We love you all. We know that you guys have a good heart to want to do more with your kids. So thank you for that. All right. Take care, everybody. Again, we'll be staying here if you have any questions for us, but answer that survey for us. All right. Thank you.
Have fun with volcanoes and earthquakes.
In a good way.
In a good way. That's right, Liz.